as the question says, water falling from a 50-meter high fall is to be used for generating electric energy. If 1.8 into 10 to the power 5 kg of water falls per hour and half the gravitational potential energy can be converted into electrical energy, how many 100-watt lamps can be lit? Now they are asking us for the number of 100-watt lamps. So if we found out somehow the total power that is generated, we will be simply dividing that by the power of each lamp, and will be easily able to find the number of lamps. So the question comes of finding the total power. Now which power? This is the electric power. So somehow we will calculate the total power due to the gravitational potential energy, and then we will half it because they have given it half the gravitational potential energy, and then find out the electrical energy that is being generated per unit time. Proceeding with this question, we have the height being 50, the mass being 1.8 into 10 to the power 5, and the power of each lamp being 100 watt. We need not to write it. So potential energy will be mgh. Rather, it is actually mg delta h. So delta h is h here. Putting the values, we get 882 into 10 to the power 5 joules. Now, what this is actually is, if we calculate the power, then it will be 882 into 10 to the power 5 joule per hour. Because actually this was kg per hour. So everything if I put in per hour, then we will be getting the power as this, right? Now what is the electrical power? If I write down it as the P with the subscript of E, then it will be giving me the electrical power, which is actually 441 into 10 to the power 5 joule per hour. But since we need to find out everything in the SI system, we will be converting into joule per second. So dividing it by 3600 will give us it in joule per second, that is equivalent to watt. And now we will be able to find the number n by dividing the total electrical power by the power of each lamp, that is 100, giving us 122.5 approximately. Now this means that 122 lamps can be lit, but the other one cannot be because it is 0.5. It would have been lit by, if there would have been one hole, that is, it is lacking with some power to actually make 123. So we will be writing it as 122. Don't approximate it as 123 because it won't be able to supply that much of power. Keep this in mind.